Surprisingly, this is week 10 already, right? And we will learn about software engineering ethics. And today learning outcome, we will learn about ethics. What is the software engineering codes of ethics? What is the intellectual properties? These are the two additional reading materials that you can check as well. You know, the content of this lecture is actually based on these two materials. The first one is the book Ethics for the Information Age by Michael Quinn. It is based on the chapter 2 and the chapter 9, and we will talk about the software engineering code of ethics and the professional practice as well, which is based on the version 5.2. Okay, first of all, right, before we move on, we need to understand what is the software engineering and why the ethics is really important here. Okay, so let's say when you work in a software development projects, you need to learn to work with the others, and it is part of being a good software engineer as well. You need to work in a team, you work within a company, you work within the society, right? And when you develop a piece of software, actually it will be used by millions of users. So there is a lot of powers that one piece of software can impact people's life, and if you watch one of the movie, with the great power comes with the great responsibility as well. So let's assume that you go to the hospital, and the hospital use one software that will automatically prescribe what is the medication that you really need. But what if there is a bug in that the medication software? You may get different incorrect prescription, incorrect medication, that kind of thing, and actually it will impact you, cause harm to your life. You will be dead as well because of the bug in the software system. You can think about the so that kind of thing. So the impact of the software system actually it causes a lot to our life. And when we talk about the quality of the software projects, right, software products, we also need to talk about the quality of the software engineers as well. And there are different quality attributes for the software products, right? We talk about the functionality, correctness, whatsoever, usability, but what are the quality attributes of the software engineers? So we need these are just a few examples that we need to think about. Being a good software engineer is that you should be a hardworking person, you should be intelligent, you should be sensible, make the right logic reasoning, and you should be up to date. And the most important part is that you should be ethical as well. So we don't want to hire someone that is unethical. And this is some of the example story. That's why we need everyone to have a good ethics in mind. Okay, let's read this one together. Wally, I discovered a deadly safety flaw in our software product. So who should I inform? Okay, who should I inform? This guy said, no one. The stock would plunge and we would have massive layoff. Your career would be ruined. Oh my goodness. Okay, but my negligence, could cause deaths of a dozen of customers as well. Yeah, that's right. So the first dozen is always the hardest one. So some way, somehow, this person, right, they just neglect that kind of deadly safety flaw in the product, right, which is not good at all. We should avoid this kind of habit. It's not a good practice. So let's take a look at another example. How hard would it be to program our website to collect browser history from our visitors? How hard it would be to program our website to collect browser history from our visitor. Well, first I would need to invent some sort of device that reverse my sense of right and wrong. So are we talking about a week or a month? Then probably the first question I should ask you is that, is this really ethical or not, right? To collect the browser history from our visitors, based on this discussion? I would say that it's not, right? Because this is a personal data. Otherwise, people will keep track everything what you have browsing, So, yep, that's not a good way as well. So, when we talk about the ethics, right? There are 2 point of view, okay, that we can consider. First, they call selfish point of view. So it means that you only consider about yourself, your own core values. You don't consider about the other people at all. But on the other hand, okay, it's called ethical point of view. So that means you respect other people and their core values as well. Back to this example, right? When we collect the browser history from our visitors, that's their personal information, right? Then the question is that, are we respecting the visitor or not? That's how we respect the other people and their core values, right? We need to think about whether they allow us or they are keen for us to collect the browser history or not as well. So this is something that we need to be careful when we implement any feature. For each of the feature, we need to think first whether this is ethically aligned to the to any principles, or morality or not. Okay. Yep. All right. So in this slide, we need to determine whether it is a good thing or the bad thing. Is it the right way or the wrong way? We normally discuss based on the morality, okay, or the ethics, okay. And what does it mean by the morality? Okay, so morality is the principles concerning the distinction between the right or wrong, the good and the bad behavior. It is a kind of like a society rules of conduct, right? And so that's the morality. Yeah, do you have morality or not? Yeah, so that's what we need to. That's the capability of a people to decide whether this is a good or the bad behavior. Okay. But ethics is something like more philosophy. It is a branch of the philosophy that involves systematizing, defending, recommending concepts of the right and the wrong conduct. Okay, it's more like the rational examinations of the morality. So morality and ethics, they are different. Morality is about yourself. You can determine whether this is a good or the bad thing, but whether it is aligned with the ethics, that's more like a theory, the concept. Yeah. Yep. Again, this is the difference between the morality and the ethics. Okay. Yeah. Morality is more practical, but ethics is more theoretical. All right. But the key question is that why do we need to study ethics, right? So because we need to learn, we need to have some principles in mind. It is a way to decide the best thing to do when dilemma happens, and when right now there are lots of problems with the new technology. Think about the AI. So we need to think about whether the AI products or the software products that we deploy to the millions of users, they are ethically aligned with the principles, responsible AI principles, that kind of thing or not, or just like we just deploy and we will not have any quality assurance practices to guarantee that the product that we deploy is safely used. Okay, so yeah, that's why we need to be careful about the ethics, because and one day if the software that you deploy is not ethical, it will cause a huge cost $1 million to the company and the organizations as well, and the reputation as well. Yeah, that's right. So this is a few scenarios, right? Let's think about this one together. An inspector discover faulty construction equipment and apply a violation tag. Okay, preventing its continued use. Yeah, so think about that. There's a machine, faulty construction equipment. Okay, this is like a building site, and some construction equipment is wrong. There is a faulty, and that's why they apply a violation tag. Warning, this one is not ready to use. Okay, the inspector, supervisor, and the construction manager view the case as a minor issue. Wow, in relation to the safety regulations, and order the tag be removed so that the project would not be delayed. Okay, The continued use of the equipment led to the death of a worker on a tunnel project. Think about the suburban rail loop. So, who is right, who is wrong? Can you type in the Zoom chat? Whose fault? Whose fault? So I would say, right? I think the inspector did the right thing. They applied the violation tag. But here, probably the inspector supervisor and the construction manager here, some way, somehow, they view the case as a minor case, minor issue. So that's why probably I would say that for this part, the supervisor and the construction manager may not be the right person. They are not ethical. They are the wrong party, And the second question is that whether this is the legal or the ethical issues. Yeah. So I think that it could be both as well. So I don't have a chance to check the Work Health and the Safety Act, this one, right? Yeah. So it could be both. First, they may break the legal issues, and second, they are not ethical as well, because safety should be the number one priority, So yeah, in this case, I would say that could be both, yeah, legal and the ethical issues. Yeah, they are not a good person to work with at all. Okay. All right, next. Okay, scenario 2, trolley problem. Okay, the trolley, what is that? Trolley. Consider a person tied to the track. A train. Is that a tram or the trolley? Look like a tram. Consider a person tied to the tracks and a train fast approaching. Oh my goodness, okay. This person is tied to the track. The train is fast approaching. The train has lost its driver. Oh my goodness. So the train is going to keep going no matter what, okay, for our purpose. There is a lever switch, okay, there's a lever on the train track probably, which can be pulled to divert the train along a different branch of the tracks. So avoid harming the person who is tied to the track, right? And now you are a bystander who understands the use of the switch, the lever, and has the capacity to pull it. Do you have moral duty, responsibility to pull the lever and thus protect, save the life of the person who is tied to the track? Yeah, would you do it or not? This is part of the, okay, Civil Engineering Canada. That's the case in from this one, Engineering Canada. Yep. Would you do it or not? Mm-hmm. Yeah, in this case, if I were you, yes, definitely. I think we need to do it, right? To save one people's life. They will really appreciate you. Yep. Mm-hmm. Yeah, so we need to say yes here. All right. All right, I'm ethical. Next. No, there might be 5 people tied to the other track. It's not written in the case. So, yeah, we assume that there is only one. Okay. Scenario 3. Suppose you install a pirated copy of the game, PC game Cyberpunk 2077. Your friend gave this to you, so technically you did not steal this from any person, right? Okay. Someone just give me a pirated copy of the PC game. Okay, I really want to play this one. What should I do? Yeah. Are you doing anything wrong? Yeah. That's the first question. Am I? Someone give it to me. I didn't do anything wrong. Is that true or not true? It's wrong because it is pirated. Yes, that's right. Yeah. So I start doing it wrong because despite although I didn't steal this game from any person, right? But I still use the pirated copy of the PC game. So it is something that is quite wrong. Okay, it's not ethical at all. who benefits, okay, who gets hurt? No one get benefit, no one get hurt anyway. And does it make a difference if it is a software from a small startup game company? Yeah. We should not consider install any pirated copy anyway. What other information might help you answer these questions? Okay, no, we don't need anything probably. Yeah. So, okay, go back to this one. Morality. What is moral? What is legal and not identical? Yeah, that's a different thing actually. Morality, whether it is legal or not. Normally, sometimes the ethical problem arise when there are different judgment and the expectation. For example, okay, what extent should an employer or supervisor directive be the authoritative guide to an engineer conduct? Oh, okay. What does one do when there are differences in judgment? Yeah, is an engineer to do more than what the specifications say? So this is a sensitive question already, right? It's not just about moral, but it's about the responsibility, the scope. That's why there are rules, legal, to protect the workers. There must be a scope that is agreed between the supervisor and the employer, that kind of thing. So that's why we have that kind of things to protect people. And that's how the software engineering code of conduct comes in, okay? Technically, there are different types of the code of conduct. Okay, so it could be a field study. There's a code of ethics or professional ethics. There are different code to practice, to follow, right? And when we talk about the ethics here, okay, it is part of the profession. Okay, it is part of the profession. When you work as a software engineer, it is a professional job, and ethics is part of the profession. That's what I mean. And there must be a standard or something, right? Because this is a professional. So what is the standard code of ethics for the software engineers? Okay, that's the one. Okay, software engineering code of ethics. Maybe I should go back to this one. That's why we need the code of ethics, which is a practical framework for moral decision making related to the problems that software engineers may encounter. That's the role for the code of ethics, okay? And it is the principles of responsibility that outline how to promote the public good as well. And the key point, it should be, this is more like a shared standard. Everyone need to follow. It provides a support to lots of people, lots of stakeholders. It is a guidance, and it is also an inspiration as well. It will provide as an education resources, create a mutual understanding among the profession, okay? And yeah, that's the thing. That's a key point. Why do we need the code of ethics? And history here is that IEEE, Computer Society, right? They create the first code of ethics since 1993, okay? And the ACM also created in 1993 as well. And later on, 3 years after, they combine into to include equal numbers of members in a joint steering committee. Yeah. And the mission of both ACM and the IEEE Software Engineering Code of Ethics is that they want to establish the appropriate sets of criteria or norms, right, for the professional practice of software engineering upon which industrial decisions, professional certificate, educational curricula can be based on. Okay, that's quite important. Otherwise, if I were you, right? If there is no standard here, then the key question is that how can we teach the ethics to the student properly? Maybe Monash University teach one set of ethics, and probably other uni also teach differently. So there's no standard, and it will create problems in the future. Okay, so that's why we need this one. And they create the 3 task force. Okay, first they want to create the body of knowledge and the recommend practices. They want another task force. They focus on the ethics and the professional practices, and another task force they focus on the education. Okay, so that's the thing. Okay, we will talk about the code of ethics. Okay, yep. What is that? What it means, right? So it is for the code of ethics. It means that software engineers shall commit themselves to making the analysis, specification, design, development, testing, and maintenance of the software a beneficial and respected profession, right? And we need to consider these 8 principles. As a software engineers, we need to adhere to these 8 principles. We focus on the ethics in the public aspect. Client, employee, employer, product should be ethical. The judgment should be ethical. Management should be ethical. Colleagues, they should be ethical. And the self, right? Myself should be ethically aligned with the principles as well. What does it mean? We will go through them one by one, okay? Should be the next slide. Yeah, anyway. Yep. So public. So it means that software engineers shall act consistently with the public interest. And the public here, it means that software engineers shall act blah, 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 blah. I think, let me put this way. There are different code of ethics here. I'm gonna see whether I have a summary of this. I think I have a very good video here, okay? And I'm gonna open it up. That summarizes the 8 principles.
Hello! In this video, I'll talk about ethics in software engineering. There are so many people that are using computers and are affected without even noticing it. It is extremely important to know ethics that is related to design, behavior, and usage of computer systems. Firstly, software engineering involves wider responsibilities than simply the application of technical skills. Also, software engineers need to behave in an honest and responsible way to be respected as professionals. The code of ethics is like a guide that software developers should know. And finally, there is a large gray area between breaking the law and morally correct behavior. The code of ethics provides a set of principles that is morally correct. The professional responsibility has several important parts that are common in software engineering. First one is confidentiality. Often, software engineers have access to sensitive and confidential data. Every professional engineer always should respect confidentiality, even if formal confidential agreement is not signed. You cannot add, change, delete the data or share it with other people or companies. Then goes competence. This part is more complex to manage and control. Sometimes we can think that we have enough competence to implement a solution, but it could appear that we are not experienced enough. Well, usually people tend to overestimate themselves. Another issue is the intellectual property rights, and here ambiguity appears again. From one side, the new product cannot violate the rights of other companies. This means that engineers should not break the law while using external resources. On the other hand, the software should protect the customers' or employees' intellectual property. Be sure that you cannot say that it was not your job to be interested in laws, contracts, and similar things. Definitely, it is your responsibility to know and be interested in intellectual property rights. And the last one is computer misuse. Engineers might get access to clients' computers or other resources. Basically, they can do everything with that device. For example, play computer games, set up a Bitcoin miner, or even install computer viruses. You should not use these devices in the way they are not intended to be used. There is no technical tool or device to control all these aspects. That's why ACM, or the Association of Computing Machinery, and IEEE, or Institute of Electrical and Electronics Engineering, jointly created the Code of 8 Ethical Principles. They are related to the behavior of professional software engineers in decision-making that includes other people, for example, practitioners, educators, managers, supervisors, and policymakers, as well as trainees and students. This is a short preamble. As you may see, the creators of the code think about software engineering as being a beneficial and respected profession with commitment to the health, safety, and welfare of the public. In this lecture, I'll shortly present all principles. For more detailed information, please open the link that is shown in the slide. The first principle is public. Engineers shall act consistently with the public interest. No other party of the project, either it is client, a user, or an employee, is above the public interest. Engineers need to accept full responsibility for their own work. For example, if someone asks to create a computer virus that could do some damage to others, you should not do that. The second principle is called client and employer, and it tells that software engineers should do what is the best for the employee and the client by considering the public interest. Of course, these two sides often conflict with each other. One side wants to make product cheaper, the other side wants a good quality. And your responsibility is to find an agreement. Keep private any confidential information gained in your professional work. Also, engineers should tell the truth even if the project is going to fail. Another principle is product. Software engineers shall ensure that their products and related modifications meet the highest professional standards possible. As a software engineer, you need to strive for a high quality, acceptable cost, and a reasonable schedule. Also, you should ensure adequate testing, debugging, and adequate documentation. The fourth principle is called judgment. Software engineers shall maintain integrity and independence in their professional judgment. You need to maintain professional objectivity with respect to any software or related documents. Also, do not engage any improper financial practice. Next principle is management. It tells that managers and leaders shall subscribe to and promote an ethical approach to the management of software development and maintenance. As a team lead, you need to ensure good maintenance for any project on which you work, including effective procedures for promoting of quality and reduction of risk. You should be fair to your employees and realistic in cost, scheduling, quality, and outcomes. Profession. We have already discussed that software engineers should not underestimate their skills and shall advise the integrity and reputation of the professional consistent with the public interest. They need to promote public knowledge of software engineering and extend their knowledge by participating in professional meetings and publications. Colleagues. Software engineers shall be fair to and supportive of their colleagues. Encourage colleagues, assist them in professional development, and give feedback to their opinions or concerns. The last principle is self. Software engineers shall participate in lifelong learning regarding the practice of their profession and shall promote an ethical approach to the practice of the profession. To summarize, these principles seek to ask software engineers to behave ethically and to use ethical judgment in their work, as opposed to blindly following rules or client instructions. To consider who is affected by the decision they make, and to put the welfare and safety of the public above everything else. Thank you for your attention.
That's right. But somehow, yep. Okay. Maybe let's continue. Yep, there's a summary of the 8 principles of the code ethics. Okay, so the next topic that I really want to mention is about the intellectual property. It is really important. So why do we need to study the intellectual property rights, and what is that? What is the copyright? What is the copyleft? What is the fair use? You know. So, okay, so this is a very important topic. Okay. First, we need to understand the term about the conflict of interest. So let's say that users want information to be free, want to be able to do what they like, and develop user models that reflect this. Okay, what is that? Examples. This is an example. File sharing service. Okay, like Dropbox, Google Drive. they want to use and share the protect. Okay, I think I understand now. So the conflict of interest here, if you think about the Dropbox and the Google Drive, they can upload the file, anything to the server, to the Google, to the Dropbox, that kind of thing. But then the key question is that they are the creator of that content, right? So that should be protected by the creators, okay? So that's the intellectual property that should be protected by them, okay? Whoever created, okay? And somehow it is quite difficult. There are some software engineering issues here. For example, first, it's quite difficult to develop the software that meet these conflicting interests, and it is quite difficult to convince the users that somehow that some new model should be adopted. Let me put this way: think about the YouTube. You create a new video, you add some music, but how the YouTube as a software provider, right? YouTube can actually detect whether the music in your video break any license or not, whether it is like it is your own IP or not. Do you create your own music for that one or not, right? So there are lots of issues as part of the software engineering that we need to consider and think about, okay? And that's why we need to learn about what is the software piracy. And the software piracy is the unauthorized copying of the software. When you develop a game, someone just crack it and copy it, and then you won't get that money from that, right? So that's not a good practice at all, okay? And piracy, blah, 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 okay. Unlicensed software becomes too risky. So that's why next step is that we need to learn what is the license of the software system, and any unlicensed software and the malware are tightly linked, okay? So what I mean is that when you install any unlicensed software, there could be some malware, and they may want to steal some of your personal information like credit card, that kind of thing as well. So that's quite dangerous. I mean, there is a risk when you install the pirated software, okay? Yep. So the IP, IP normally refers to the creation of the mind, invention, literary and artistic work, and symbols, names, image, design used in commerce. Okay, so that means whatever you created, that's your IP. Okay, that's intellectual property. We need to protect it. Okay, and normally the copyright law, it is used to secure for the owners of the creative work the exclusive right to control who makes the copy and make work derived from the original copy. So the copyright is the law to protect the IP, okay? And normally each of the asset or creation or artifact, software whatsoever, there is a fair use doctrine as well. That means it is legal to use copyrighted material in certain situations. It really depends what is the license or the copyright, that kind of thing that is allowed, okay? Yep, so what is the IP? It is the unique product of the human intellect that has the commercial value, like books, songs, movies, paintings, drawings, software as well, the program, the algorithms, and intellectual property is not something that is physical, it is something that is not the same, okay? That's why they need to register the patent. That's the one way to protect the intellectual property, okay? So we need to protect the intellectual property. However, there are some limitations as well. So, for example, normally you want the IP protection. They only gives the creator right to their invention, stimulate the creativity, blah blah blah. I don't know what is this. Okay. Anyway, I'm gonna jump to what is the copyright, fair use, and software copyright. There is one thing that I want to emphasize here. Okay, there are different types of the software license, okay? And probably I'm gonna say that there is this video, okay, which is very good.
Gives you the right to install it. Software license is a legal instrument that gives you the right to install, use, or otherwise interact with a specific computer program under certain conditions. This permission is granted to you through the licensing agreement, which is a contract between you and the software manufacturer. The licensing agreement further specifies the terms and conditions, the usage rights, such as downgrade rights, or in other words, the possibility to use an older version of the software. Several conditions have to be met before your software can be considered licensed. For example, having a product key doesn't automatically mean you are legally allowed to use a given software. You also need to have all required documents that prove your software is licensed in a proper way. As our company is focused mostly on Microsoft products, I will describe the three main types of licenses from this producer: retail, OEM, and volume. Retail license, also known as the full package product, is probably the simplest type of license. You can buy the retail product online or in a store, and you can use the software no matter if you are a home user or company. OEM, or Original Equipment Manufacturer license, typically accompanies some sort of hardware. To give you an example, when you buy a laptop and it comes with an already installed Windows, the Windows is most likely with the OEM type of license. Volume licensing is aimed at businesses and organizations that need software products with flexible management options. Also, ordering volume products in bulk cuts the costs even more. Since our company is focused on the B2B and public sectors, we provide a volume licensed software, which is the best choice for our business customers' needs. To summarize, each type of software licensing is suitable for different type of user. We at Forescope understand that it can be hard to navigate yourself between them. That's why we are always happy to provide a free consultation to your company and help you decide which software product to choose.
So that's about software license that are normally used in the open source software projects. Okay, so for example, this is the high level. The first one is more public. Okay, public domain license. That means that anyone is free to use and modify the software. Sometimes they have some limitation as well, like LGPL. You can link to the open source libraries within your own software. But any resulting code can be licensed under any other types of the license as well. Okay. Sometimes there's a permissive use. Okay. So permissive license. That means there's a few restriction or requirement for the distributions of the or the modification of the software system as well. There's a copyleft is quite restrictive, known as reciprocal license or the proprietary use. Okay, which is the most restrictive use of the software. Okay, that means you are not eligible for copying, modifying, or distribution at all. Okay, so it really depends, you know. Yep. So what exactly is the copyleft? They say it is another play of the word copyright, and it is the practice of using the copyright law to offer the right to distribute the copies and modify versions of a work, and requiring that the same rights to be preserved in modified versions of the work as well. Okay, that's a copyleft. And it is a general method for making a creative work as freely available to be modified and requiring or modify and extend versions of the creative work to be free as well. Okay, that's a copyleft. All right. Okay. I'm gonna show you another one as well that I really want to emphasize. Okay. Before we move on. Okay. Yep. So first of all, nowadays, right? What I mean is that this is the end of the lecture already. It is quite quick. I just want to emphasize that nowadays the software is not just the website, it's not just static like a mobile apps, but normally we incorporate the AI component in the software system, right? Think about let's say you submit a job application, there might be an AI that actually predict whether your job application is qualified or not, right? And then think about one day one day you get an email notification that, hey, you are not eligible. This decision is made by the AI. Then your question probably you may ask, right? Like, why? Why is that? Why that happens to me? Is that fair or not, right? That's why right now when we integrate the AI into the software system, we need to consider about this principle. It's called responsible AI principles. Okay, maybe actually I should first show you the case about the unfairness or unethical cases in the AI software system. Okay. Yep. This is the algorithmic bias. Maybe I will show you this one. Yep.
You've likely heard the term artificial intelligence thrown around the last few years. AI is the ability of computers and machines to perform tasks humans can do, and it is all around us. For example, consider a typical bedroom. Gmail can autocomplete your sentences as you are writing an email. When you ask, "Hey Siri, what is the weather today?" your phone lights up to tell you the weather forecast. Alexa, along with other voice processing systems, can also parse audio input and complete tasks at your request. AI also has many commercial uses. Companies can decide who to interview and hire, and banks can approve or deny loan applications. If these algorithms are built correctly, they can increase the efficiency, reliability, and objectivity of decision-making processes. Let's take a closer look at how banks can use AI. More specifically, the bank uses machine learning, which is a branch of AI where algorithms learn a task by analyzing data instead of using explicit instructions. Let's say the bank knows from your application how many years of education you have completed. It also knows your spending habits from your credit card history. These data features, and many others, can be inputted to an algorithm that decides whether the bank should lend you money. This algorithm, in turn, has been trained with previous data of customers who have repaid their loans and those who have not. The training process uses trends and patterns from this input data to predict whether a person will repay the loan. Then, by comparing the predictions with the actual outcome, the algorithm can be fine-tuned. This can be done by changing the weights of nodes or including more hidden layers of data manipulations. So when the bank receives someone's application, it can use the algorithm to reliably decide whether a loan should be made. This is an example of binary classification, where only two types of results are possible. But real life is usually more complicated, and the bank can also create an algorithm that outputs continuous results. For example, it can output an interest rate, so someone with a higher chance of repaying will have a lower interest rate, and vice versa. However, AI is not perfect. Because it only learns from a given set of data, the predictions it outputs are extremely reliant on what the training data was like. This means that bad data can give rise to a bad algorithm. But not only is the outcome of a bad algorithm unreliable, it can be unfair. How could an algorithm possibly be unfair? First, because data is accumulated over time, it may contain historical biases. Second, because data is also gathered and labeled by humans, it may contain societal biases. This means that an algorithm will be trained to follow the same biases and treat individuals differently because of their membership in a certain gender, race, religion, geographic location, or other types of demographic groups. Rather than looking for accurate indicators and trends, the algorithm will then be influenced by these sensitive attributes in the data and replicate or even amplify existing biases. Here are some examples of biased AI in practice. Natural language processing is a branch of AI that studies how machines understand and analyze human language. Because it is easier for machines to handle numbers rather than words, we represent words using vectors of numbers. These are called word embeddings. Here, we represent the embeddings as vectors in two-dimensional space, but the logic behind the embeddings still work the same way. Meaning is captured by the direction and magnitude of the vector. so we can expect the words fairness and justice to have closely associated embeddings. However, researchers found in 2016 that commonly used word embedding frameworks contain disturbing gender stereotypes. An algorithm associated men with the terms doctor and computer programmer, and women with nurse and housewife, after it was trained on a news database. This isn't a trivial matter of counting pairs of words that occur together. In fact, the term male nurse even occurred more frequently than female nurse. Instead, the training process is able to extract associations, relationships, and biases that are embedded underneath the raw text. As a result, when natural language processing is used to understand an input sentence or provide word suggestions, the algorithm's output will be biased. This can get unfair in some settings. For example, if a company is hiring recent science PhD graduates and searches for candidates online, the search engine's natural language processing will try to understand its meaning and look for the closest match. But this means that a male graduate is more likely placed first, as science is more closely associated with male names. As a result, biases in word embeddings can not only reflect stereotypes, but also further amplify them. Biased training datasets can also be found in practice in facial recognition systems. Last summer, researchers published a new machine learning tool called Pulse that generated high-resolution images from low-resolution inputs. People quickly found that Pulse generated white faces much more often than faces of people of color. The fact that this tool was published without any researchers noticing this trend of bias showed how the problem of bias goes far deeper than any dataset or algorithm. It's an issue that requires conscious awareness and consideration throughout the building process. In another striking demonstration of the problem, in 2018, researcher Joy Buolamwini found that facial recognition systems were not able to detect her face until she put on a white mask. Subsequent research by her and other researchers found that many prominent facial recognition systems, including those built by IBM, Amazon, and Microsoft, were much less accurate for women and dark-skinned individuals. This discrepancy in bias is a big problem when facial recognition is already so prevalent today.
That's right. So yeah, that's what I want to emphasize. Right now, AI is used nowadays for the facial recognition whatsoever, and there is a bias in the AI system, right? And what I mean is that in the future, or right now, I would say not in the future, right now, there is one thing called responsible AI principles that are applied into many companies. We just want to make sure that any software developed with the AI component are responsible to the society. Okay, so probably I'm gonna open this one as an introduction to the responsible AI principles.
Hello,
to
and
you.
welcome to Introduction to Responsible AI. This course will help you understand why Google has put AI principles in place, identify the need for a responsible AI practice within an organization, recognize that decisions made at all stages of a project have an impact on responsible AI, and recognize that organizations can design AI to fit their own business needs and values. Many of us already have daily interactions with artificial intelligence, or AI, from predictions for traffic and weather to recommendations for TV shows you might like to watch next. As AI becomes more common, many technologies that aren't AI-enabled may start to seem inadequate. Now AI systems are enabling computers to see, understand, and interact with the world in ways that were unimaginable just a decade ago. And these systems are developing at an extraordinary pace. Yet, despite these remarkable advancements, AI is not infallible. Developing responsible AI requires an understanding of the possible issues, limitations, or unintended consequences. Technology is a reflection of what exists in society, so without good practices, AI may replicate existing issues or bias and amplify them. But there isn't a universal definition of responsible AI, nor is there a simple checklist or formula that defines how responsible AI practices should be implemented. Instead, organizations are developing their own AI principles that reflect their mission and values. While these principles are unique to every organization, if you look for common themes, you find a consistent set of ideas across transparency, fairness, accountability, and privacy. At Google, our approach to responsible AI is rooted in a commitment to strive towards AI that's built for everyone, that's accountable and safe, that respects privacy, and that is driven by scientific excellence. We've developed our own AI principles, practices, governance processes, and tools that together embody our values and guide our approach to responsible AI. We've incorporated responsibility by design into our products, and even more importantly, our organization. Like many companies, we use our AI principles as a framework to guide responsible decision-making. We all have a role to play in how responsible AI is applied. Whatever stage in the AI process you're involved with, from design to deployment or application, the decisions you make have an impact. Therefore, it's important that you too have a defined and repeatable process for using AI responsibly. There's a common misconception with artificial intelligence that machines play the central decision-making role. In reality, it's people who design and build these machines and decide how they're used. People are involved in each aspect of AI development. They collect or create the data that the model is trained on. They control the deployment of the AI and how it's applied in a given context. Essentially, human decisions are threaded throughout our technology products. And every time a person makes a decision, they're actually making a choice based on their own values. Whether it's a decision to use generative AI to solve a problem, as opposed to other methods, or anywhere throughout the machine learning lifecycle, that person introduces their own set of values. This means that every decision point requires consideration and evaluation to ensure that choices have been made responsibly from concept through deployment and maintenance. Because there's potential to impact many areas of society, not to mention people's daily lives, it's important to develop these technologies with ethics in mind. Responsible AI doesn't mean to focus only on the obviously controversial use cases. Without responsible AI practices, even seemingly innocuous AI use cases, or those with good intent, could still cause ethical issues or unintended outcomes, or not be as beneficial as they could be. Ethics and responsibility are important, not least because they represent the right thing to do, but also because they can guide AI design to be more beneficial for people's lives. At Google, we've learned that building responsibility into any AI deployment makes better models and builds trust with our customers and our customers' customers. If at any point that trust is broken, we run the risk of AI deployments being stalled, unsuccessful, or at worst, harmful to stakeholders those products affect. This all fits into our belief at Google that responsible AI equals successful AI. We make our product and business decisions around AI through a series of assessments and reviews. These instill rigor and consistency in our approach across product areas and geographies. These assessments and reviews begin with ensuring that any project aligns with our AI principles. While AI principles help ground a group in shared commitments, not everyone will agree with every decision made about how products should be designed responsibly. This is why it's important to develop robust processes that people can trust. So even if they don't agree with the end decision, they trust the process that drove the decision. In June 2018, we announced 7 AI principles to guide our work. These are concrete standards that actively govern our research and product development and affect our business decisions. Here's an overview of each one. 1. AI should be socially beneficial. Any project should take into account a broad range of social and economic factors, and will proceed only where we believe that the overall likely benefits substantially exceed the foreseeable risks and downsides. 2. AI should avoid creating or reinforcing unfair bias. We seek to avoid unjust effects on people, particularly those related to sensitive characteristics such as race, ethnicity, gender, nationality, income, sexual orientation, ability, and political or religious belief. 3. AI should be built and tested for safety. We will continue to develop and apply strong safety and security practices to avoid unintended results that create risks of harm. 4. AI should be accountable to people. We will design AI systems that provide appropriate opportunities for feedback, relevant explanations, and appeal. 5. AI should incorporate privacy design principles. We will give opportunity for notice and consent, encourage architectures with privacy safeguards, and provide appropriate transparency and control over the use of data. 6. AI should uphold high standards of scientific excellence. We will work with a range of stakeholders to promote thoughtful leadership in this area, drawing on scientifically rigorous and multidisciplinary approaches. And we will responsibly share AI knowledge by publishing educational materials, best practices, and research that enable more people to develop useful AI applications. 7. AI should be made available for uses that accord with these principles. Many technologies have multiple uses, so we'll work to limit potentially harmful or abusive applications. In addition to these 7 principles, there are certain AI applications that we will not pursue. We will not design or deploy AI in these 4 application areas: technologies that cause or are likely to cause overall harm, weapons or other technologies whose principal purpose or implementation is to cause or directly facilitate injury to people, technologies that gather or use information for surveillance that violates internationally accepted norms, and technologies whose purpose contravenes widely accepted principles of international law and human rights. Establishing principles was a starting point rather than an end. What remains true is that our AI principles rarely give us direct answers to our questions on how to build our products. They don't, and shouldn't, allow us to sidestep hard conversations. They are a foundation that establishes what we stand for, what we build, and why we build it. And they are core to the success of our enterprise AI offerings.